Howdy. Let's start off with some earthquakes and then we check out some microwave experiments. An hour ago there has been a 4.4 at Svalbard, 10 kilometers in depth. Maybe. Also, there has been deeper quakes near Svalbard 2 days ago, 23 kilometers in depth. Or is that the same? Yeah, they are both 23 kilometers in depth. And also here, somewhere, here, out in the middle of nowhere, 6 days ago, 1.4. There might be something on the seafloor in the vicinity of that quake too. And one has been here somewhere, here, Mayen, 6 days ago. So we are watching at 7 days of quakes. Earthquake filter, 7 days. The thing is, we have something going on in the Baltic Sea between Gotland and Lithuania. And there are several locations where we have several quakes in the same place. 6 days ago, 2.3. 2.2 6 days ago. And a 2.1. So 3 quakes at this location. Here we have 2, I think. 2.2 also 6 days ago. And a 2.0. Yeah, there were 2 quakes, and here we have 2 as well, I think. 6 days ago. So they all happened at the same day. 2.3 and a 2.2 and a 2.0 4 days ago. 2.3 6 days ago and 2.0 4 days ago. 4 days ago 2.0. This we already watched. 5 days ago 2.5. 1.9 5 days ago. And it seems they are moving. 7 days ago, 5 days ago. So that's why I made the video, because I somehow knew that soon some of them will vanish. 6 days ago. So tomorrow there will be much less quakes visible here on this place. 2.4 3 days ago. So we have, I think, another quake as well at the same location. So let's try. 2.4 2 days ago. So 2 quakes at this location. Here is just 1 2 days ago. 2.2. 2.3 5 days ago. So they are all more or less from the same magnitude. But it continues. 5 days ago 1.9. 3 days ago 2.7. 6 days ago 2.1. 5 days ago 2.6. 5 days ago 2.6. 7 days ago 1.9. And 6 days ago 4.2. Let's go quickly to check it out. Yeah, nothing too obvious. So I find this very interesting, that we have so many quakes in the Baltic Sea. I haven't checked any pipelines or data cables or whatever else stuff some people probably would care about. We have an unconfirmed in England 3.8 as always. But anyway, as you can see on the 7-day quake map, we have quite something going on. Also up in Scandinavia and beyond. But now let's check out some microwave experiments. So that's the pebble. And let's check it out how it looks. I didn't do anything to that. I didn't clean it or whatsoever. So there might be some dust. But let's have a look at it. It has some very interesting inclusions, and it's yellow. And it has some quartz, and it's interesting. Interesting pebble. And I thought that, yeah, since there's yellow, there might be some iron inside, and let's see if it does anything if I put it in the microwave. And yes, it did. After some time, it started to do stuff. It started to glow. Yeah, you have noticed there's a little break because I ran out of memory space. So now, as we have action, I started again to record. And at one point, it makes some very nice plasma stuff. Yeah, that's not the stone which makes those sounds. And you can see the glass is a bit broken because the stuff gets really hot there. That is very annoying because we have this grid inside the microwave. So it's not really possible to focus on that because it always picks up the grid and those lines which are there, and it's very annoying. What to do? Niin, se on tuon tietokoneen juttu. And I think it's very interesting to see how it immediately starts to glow more as the microwave are turned on. Because if you have a microwave and you put the, what is it, the input or whatever stage of the intensity, it's basically always the same, but the interval is just longer. And I have it at full power, 800 watts, whatever that means. But immediately as you hear the lower sound, then the microwave are on, and nah, let's watch it again. Yeah, this was the most action it got. Yeah, it's buzzing. I tried to capture the plasma, but it doesn't work. Let's watch again this most interesting part of all. So now let's think about Earth's magnetic field weakening. We get some induced currents, which might be very strong. And the Earth is heating up, and there's just electricity flowing through the crust, the mantle, or wherever it's going, just beneath our feet. And it hits a stone like that, and it gets really hot. And we could somehow expect something like this emerging from the ground as well. And as you watch how I try to get this, oh man. I just want to point out that where we can see that the flame is separating, we have to remember that it is still connected. Or those two parts of the flame are still connected. Now it got really bright there. There is a connection between this part and this part. Even though we cannot see it here, we just can admire this metal grit, which is, and the reflection of the glass. Now let's watch it once again. Actually, we need sound for that. Because this sounds really much like welding. And that's the first picture after I took it out of the microwave oven. We have something going on here. Yeah, I know it's not the best picture, but as you have probably noticed, I haven't been alone, so I had a supervisor. But the pebble is now different. And it was still a little bit glowing inside. I couldn't capture it with the camera. We have to see how it looks when it's cold. And I think I will still continue to microwave this pebble. Let's see what else it can do. Does it do anything else? Is there more action happening? Or whatsoever stuff. But it's very interesting. Because, for example, the title of my first paper, Plate Tectonic Issues, the Influence of Electricity in Rock-Forming Processes. So no one can tell me that electricity doesn't have any influence in the rock-forming processes, because I proved it to myself now several times with a microwave. And the microwave oven, commonly referred to as microwave, is an electric oven that heats and cooks food by exposing it to Electromagnetic radiation in the microwave frequency range. This induces polar molecules in the food to rotate and produce thermal energy in a process known as dielectric heating. Microwave ovens heat foods quickly and efficiently because excitation is fairly uniform in the outer 25 to 38 millimeters of a homogeneous, high water content food item. The development of the cavity magnetron in the United Kingdom made possible the production of electromagnetic waves of a small enough wavelength. They're actually rather long, those microwaves, compared to other waves. But anyway, a modern microwave oven 2022, the one I use is many years older. Doesn't matter, but because we have the results, you can transmutate minerals in stones into other things by using microwave as a tool. And electromagnetic radiation. You can make geological experiments. You don't have to move any continental plates. You don't have to capture any asteroids. You don't need billions of years. You don't need to travel to any volcano or whatsoever. But I just recommend to you, if you want to try these kinds of same things, I really recommend you to do it because it's very fun. Use an old microwave, because if there's really sulfur in the stone, you won't use that microwave anymore for food because, yeah, it smells like hell. Literally. For those who have seen the copper hexology and know about Venus and its sulfur and know about Satan and hell, brimstone, you know what I mean by saying it smells like hell. But anyway, I leave it here. Thanks. Bye.